This flash on the moon lasted less than 1 second, but it revealed something shocking. Earlier this month, something extraordinary happened. For less than a second, a tiny flash of light appeared on the surface of the moon. No explosion, no sound, no warning. Just a brief spark, captured live by a telescope on Earth. Most people would have missed it. Most scientists never see one in their entire careers. But this moment was different. Because that flash wasn't random. It was the violent end of a space rock traveling faster than a bullet, slamming into the moon in real time. Today, on AED, we're breaking down what was observed, why this event matters far more than it looks, and what it reveals about the constant, invisible danger surrounding the moon. Let's begin. The moment IT happened. On December 12th, 2025, at exactly 3:09 UTC, a robotic telescope was quietly monitoring the moon. Nothing unusual, no alerts, no expectations. Then, suddenly, a flash, less than a second long. Small, sharp, unmistakable. The observer saw it live on screen. Not later. Not in replay. Not through software detection. Live. That alone makes this event incredibly rare. Most lunar impact flashes are discovered only after hours of reviewing footage, frame by frame. To witness one in real time is like seeing lightning strike the same spot you'll be staring at. Even veteran lunar observers may never experience it once. Why the conditions were perfect, this impact wasn't just luck. The moon itself helped to reveal it. At the time, the moon was near the new moon phase. That means most of its surface was in darkness. No sunlight washing out faint flashes. Perfect contrast against the blackness of space. If this impact had occurred on the sunlit side of the moon, it would have been completely invisible from Earth. Countless impacts happened there every year, unseen. This one occurred in exactly the right place, at exactly the right time. What actually hit the moon? Early analysis suggests the object was tiny, probably only a few centimeters across. So why did it produce a visible flash? Speed. This object was traveling at tens of kilometers per second, estimated around 35 kilometers per second. At those velocities, size doesn't matter. Even something as small as a marble carries enormous kinetic energy. When it struck the moon's surface, that energy was released instantly as heat light shock. That conversion produced the flash observers saw from Earth. Where did he hit? Using frame-by-frame analysis and telescope orientation, astronomers estimate the impact occurred slightly northeast of the Langrenus crater, a prominent feature on the moon's near side. Pinpointing exact locations isn't simple. Scientists must account for viewing, angle, timing, accuracy, instrument response, lunar geometry, but even an approximate location is valuable. This detection marks the first confirmed lunar impact flash recorded from Ireland, only the second ever documented from the British Isles. That alone makes it historically significant. The Geminid connection. Here's where the story gets even more interesting. The impact happened during the active window of the Geminid meteor shower, one of the strongest and most reliable meteor showers on Earth. The Geminids peak every December. Fast, bright, reliable. But unlike most meteor showers, the Geminids don't come from a classic icy comet. They come from something unusual. A strange source. 3,200 Phython. The Geminids originate from a rocky object called 3,200 Phython. It behaves like an asteroid, but sheds debris like a comet. When it passes close to the sun, intense heat causes it to fracture and release particles. Over time, this creates a dense stream of debris. Earth passes through that stream every December, producing the Geminid meteor shower. But Earth isn't alone. The moon is in the firing line. The moon travels through the same region of space, but unlike Earth, the moon has no atmosphere, no protection, no burning meteors. Everything hits the surface directly. If this impactor came from the Geminid stream, it didn't burn up. It slammed straight into lunar rock. The estimated impact speed matches Geminid velocities almost perfectly. While scientists can't confirm the origin with absolute certainty, the timing and physics strongly support the connection. Why this one flash matters. This was a small impact. But scientifically, it's huge. Lunar impact flashes give scientists direct measurements of impact frequency, data on small object populations, insight into near-Earth debris behavior. Large impacts are rare and well-studied. Small impacts are constant and mostly invisible. Each confirmed flash fills a gap in our understanding. A natural laboratory. The moon is a perfect test site. No atmosphere, no erosion, no weather. Every impact preserves pure physics. When scientists measure flash brightness and duration, they can estimate energy released object size velocity over time. These observations refine models of the solar system's debris environment. Why this matters for the future: humanity is returning to the moon. Permanent habitats, scientific instruments, communication systems, even small impacts pose cumulative risks. Understanding how often impacts occur, how energetic they are, is essential for designing protection. This isn't abstract science. It's future survival planning. From rare event to routine science, thanks to improved imaging, automated detection. Global telescope networks, what was once incredibly rare, may soon become routine. In some cases, orbiting spacecraft can even search for fresh craters, matching observed flashes. Even when no crater is found, that absence still improves size estimates. A dynamic moon, not a dead one. We often think of the moon as static, dead, silent, unchanging. This flash proves otherwise. The moon is constantly interacting with space, bombarded, shaped, evolving, quietly. That flash on the moon lasted less than a second, but it revealed something profound. The solar system is not calm. Space is not empty, and the moon is not untouched. Invisible debris is always moving, always colliding, always reshaping worlds. This time, we caught it live. And as our eyes on the sky improve, moments like this won't just surprise us. They'll teach us. You're watching AED ID, where science becomes story and the universe reveals itself, one flash at a time.